All right, so again, we are practicing solving each equation by factoring. We will be learning a new way to solve today. This first one, 15x squared plus 39x plus 18 equals 0. Remember, we're always supposed to check for a GCF first, and this one does. They are all divisible by 3. So this is really 3 times 5x squared plus 13x plus 6 equals 0. So my A, I should be using 5, B 13, C 6. Draw my box. Five x squared goes in the upper left, 6 goes in the bottom right. By this point, if you can't even do that, then we need to seek out additional help, because all that is doing is pulling from the equation. You're not doing any math there. Go to my x. I know my A times C goes at the top, B goes at the bottom. 5 times 6 is 30. B is 13, so I need two numbers that multiply together to make 30 and add up to 13, which would be 10 and 3. So one of these boxes is 10x, the other box is 3x. And again, what I'm looking for is what started outside. So if I look up here, 5x squared and 3x only have an x in common, which means that this other top side here has to be 5x to end up with 5x squared. The upper right, to get 10x, I have to take 5x times positive 2. The lower left, to get 3x, I have to take x times positive 3. So 3 times the quantity x plus 2 times the quantity 5x plus 3 equals 0 would be the factored form. To solve, I just have to worry about the two parentheses. I don't have to worry about the greatest common factor. So I say x plus 2 equals 0. 5x plus 3 equals 0. So x equals negative 2. 5x equals negative 3. So x equals negative 3/5. So my solution set is negative 2, comma, negative 3/5. Those are the 2 points that quadratic is going to cross the x-axis. Those are the solutions, the roots, the zeros, the x-intercepts, whatever you name you would like to go by, it all means the same thing. Number 2, 5m squared minus 22m minus 15 equals 0. So I look at 5, 22, and 15. There's no number that goes into all three of them equally. So A is 5, B is negative 22, C is negative 15. There is no GCF on this one, which means I can go right to my box. I know that my 5m squared goes in the upper left. My negative 15 goes in the lower right. Set up my x. The top of my x is A times C. The bottom of my x is B. 5 times negative 15 would be negative 75. B is negative 22. To get a negative product and a negative sum, one of my factors has to be negative. And since the sum is negative, the larger factor. So this would be positive 3 times negative 25. That gives me a product of negative 75 and a sum of negative 22. So one of these is 3m, the other is negative 25m. So if I look up here, 5m squared and negative 25m both have a 5m in common. So the other one would just be m. To get 3m, I have to take m times positive 3. To get negative 25m, I have to take 5m times negative 5. So I have the quantity 5m plus 3 times the quantity m minus 5 equals 0. That is the factored form. To solve, I put 5m plus 3 equals 0. M minus 5 equals 0. So 5m equals negative 3. M equals negative 3/5. And m equals 5. So there's my solution set, negative 3/5 and positive 5 is the 2 points where that function will cross the x-axis. All right, so quadratic formula. The thing about quadratic formula that makes it nice is you can solve any quadratic with this formula, but the formula is a little busy. The formula does require that we have standard form, so we have y equals our ax squared plus bx plus c. And again, we should know by now that that is considered standard form of a quadratic. And our quadratic formula x equals negative b plus or minus, the plus and minus are stacked there, plus or minus the square root of b squared minus 4ac all divided by 2a. Now, part of this formula should already look familiar. This b squared minus 4ac that's under the radical sign here this is the discriminant. We worked with that last week to determine how many real solutions a function has. And I told you at the time that it was part of a larger equation. The biggest problem that happens here is on the substitution, making sure we're being cognizant of all of our negative signs. That is usually where the errors happen. You also notice you see this stacked plus and minus. That means that you have two different answers. One will have a positive in there, one will have a negative. So there are two different answers. So once we get the equation simplified down, we'll run it once with the plus in there and once with the minus in there. Now today we are working with all rational answers. We will get into irrational and imaginary later in the week. But there's also one little thing we talked about this with the discriminant last week, is one side of the equation must be equal to 0 before we do any substitution. One side of the equation must be equal to 0 before substituting values into the formula. All right, so as we go to apply this here, solve each equation with the quadratic formula. And that is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So that is the formula that we're going to be substituting into. So I look at number 3, 3x squared minus x minus 30 equals 0. One side is already equal to 0, so I can label my a, my b, my c. So in this case, a is 3. Since there's nothing in front of that x, it's a negative 1 is the value of b. And negative 30 would be the value of c. So I'm going to substitute in. B is already negative. The formula calls for negative b, so you have to make sure to account for that. So x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 3 times negative 30. All divided by 2 times 3. So all I have done at that point is take my a, my b, and my c and substitute them into the appropriate places in the formula. Again, being cautious that you're taking care of those negative signs. Otherwise, your answer will not come out correctly. Now, I do have a double negative situation out here. The negative 1 would go positive. So x equals 1 plus or minus the square root. Negative 1 squared is 1. Negative 4 times 3 is negative 12. Negative 12 times negative 30 is a positive 360 divided by 6. So x equals 1 plus or minus the square root of 361 divided by 6. Is the square root of 361 a perfect square? What whole number does that come out to equal? So what is the square root of 361? It's 19. So x equals 1 plus or minus 19 divided by 6. Again, at this point, that's where I have to solve 1 plus 19 divided by 6 and 1 minus 19 divided by 6. So x equals 1 plus 19 divided by 6, which is 20 divided by 6. They can both be reduced by 2. So x equals 10 over 3. But I have to go back now. I have to do 1 minus 19. So x equals 1 minus 19 divided by 6, which is negative 18 divided by 6. So x equals negative 3. So my solution set is 10 thirds and negative 3. Those are the 2 points where that function is going to cross the x-axis. And again, today all of the problems we're working with are rational, which means we won't have a square root left in the problem if we've done our math correctly. Number 4, 3n squared plus 5n minus 50 equals 0. Again, we've already got it set equal to 0, so I don't have to do anything there. A is 3, B is positive 5, C is negative 50. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 50, all divided by 2 times 3. So again, at that point, I've just substituted in my values for A, B, and C into the formula. So I have x equals negative 5 plus or minus the square root. 5 squared is 25. Negative 4 times 3 is negative 12. Negative 12 times 50 is a positive 600 divided by 6. So I have x equals negative 5 plus or minus the square root of 625 divided by 6. What is the square root of 625? It's 25. So x equals negative 5 plus or minus 25 divided by 6. So now I'm at that point, I need to separate it out and do one with the negative 5 plus 25 and one with negative 5 minus 25. So x equals negative 5 plus 25 divided by 6, which is 20 divided by 6. Both divisible by 2. So x equals 10 thirds. And then x equals negative 5 minus 25 divided by 6, which is negative 30 divided by 6. So x equals negative 5. So my solution set is 10 thirds and negative 5. Those are the 2 points that my function is going to cross the x-axis. All right, number 5 here, 3n squared plus n minus 3 equals 11. I do not have one side equal to 0, so I need to take care of that first. It's a positive 11, so I need to subtract 11 from both sides to cancel that out, so that I have 3n squared plus n minus 14 equals 0. Because I can't do the substitution until one side is equal to 0. That's how I'll find my intercepts. Now that I have moved that 11 over, a is 3. Since there's nothing in front of the n, it's a positive 1. And c would be negative 14 in this case. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 14, all divided by 2 times 3. So I made sure that one side was equal to 0. Once that happened, I can now take my a, my b, and my c and substitute it into the equation. Now I can work on simplifying. So x equals negative 1 plus or minus the square root. 1 squared is 1. Negative 4 times 3 is negative 12. Negative 12 times negative 14 is positive 168 divided by 6. So x equals negative 1 plus or minus the square root of 169 divided by 6. And what is the square root of 169? 13. So x equals negative 1 plus or minus 13 divided by 6. So now I'm at that point where I have to separate them out and do both the plus 13 and the minus 13. So x equals negative 1 plus 13 divided by 6, which would be 12 divided by 6. So x equals 2. And then x equals negative 1 minus 13 divided by 6, be negative 14 divided by 6. They are both divisible by 2. So x equals negative 7/3. So my solution set is 2 and negative 7/3. Those are the 2 points in which that function will cross the x-axis. Number 6, 4p squared minus 2p minus 102 equals negative 12. So I need one side equal to 0. Since that's a minus 12, I'm going to add 12 to both sides. So I have 4p squared minus 2p minus 90 equals 0. Now that I have one side equal to 0, I can identify my a, my b, and my c. So in this case, a is going to be 4, b is going to be negative 2, and C is going to be negative 90. So those are the values that I'm going to substitute in. So x equals negative, negative 2. Make sure and account for those negative signs. Plus or minus the square root. Negative 2 squared minus 4 times negative 90. All divided by 2 times 4. Again, all I have done is substitute in my values for A, B, and C into the equation, getting ready to simplify. So I have the double negative out front here, which ends up being positive. So x equals 2 plus or minus the square root. Negative 2 squared is positive 4. Negative 4 times 4 is negative 16. Negative 16 times negative 90 is positive 1,440. All divided by 8. X equals 2 plus or minus the square root of 1,444 divided by 8. And what is the square root of 1,444? 38. So x equals 2 plus or minus 38 divided by 8. So x equals 2 plus 38 divided by 8, which is 40 divided by 8. So x equals 5. And then x equals 2 minus 38 divided by 8, which is negative 36 over 8. Both of these are divisible by 4. So x equals negative 9 halves. So my solution set is 5 and negative 9 halves. Those are the 2 points that that function will cross the x-axis. All right, number 7, 6x squared minus 87 equals 11x. So it's not always the constant term that could be on the other side, but I still need to move everything together. So I would have to subtract 11x from both sides, and I need to make sure it gets in the right position so I get the correct value. So this would be rewritten as 6x squared minus 11x minus 87 equals 0. And now that I have the one side equal to 0, I know that A is going to have a value of 6. B is going to have a value of negative 11. And C is going to have a value of negative 87. And now I'm at the point I can substitute those values into the formula. So x equals negative 11 plus or minus the square root negative 11 quantity squared. When you write that negative 11 or any negative in the radical to square it, you have to make sure the negative is in parentheses. Minus 4 times 6 times negative 87 all divided by 2 times 6. So again, the double negative out front with the 11. So x equals 11 plus or minus the square root. Negative 11 squared would be 121. Negative 4 times 6 is negative 24. Negative 24 times negative 87 is positive 2088. And that's all going to be divided by 12. It's just a matter of simplifying the math in the formula. So x equals 11 plus or minus the square root of 2,209 divided by 12. And what is the square root of 2,209? Gets you 47. So 11 plus or minus 47 divided by 12. So x equals 11 plus 47 divided by 12, which would be 58 divided by 12. They're both divisible by 2. So x equals 29/6. And then x equals 11 minus 47 over 12, negative 36 over 12, x equals negative 3. So my solution set is 29/6 and negative 3. Number 8, 17b squared minus 8b minus 69 equals 12b squared. So I need to move over that 12b squared by subtracting it from both sides. So 5b squared minus 8b minus 69 equals 0 is the values that I need to be working with. A is going to have a value of 5. B is going to have a value of negative 8. And C is going to have a value of negative 69. So x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 5 times negative 69, all divided by 2 times 5. So just substituting in the values there into the equation. I have a double negative out front here. So x equals 8 plus or minus the square root. Negative 8 squared is positive 64. Negative 4 times 5 is negative 20. Negative 20 times negative 69 is positive 1,380. And that's all going to get divided by 10. So x equals 8 plus or minus the square root. 64 plus 1,380 is 1,444 divided by 10. We've already taken the square root of 1,444 and we got 38, so x equals 8 plus or minus 38 divided by 10. And now I can separate them out. I have x equals 8 plus 38 divided by 10, which would be 46 divided by 10. Those are both divisible by 2. So x would equal 23/5. And x equals 8 minus 38 divided by 10, which is negative 30 divided by 10. So x equals negative 3. So my solution set is 23/5 and negative 3.